Okay, so you have done all these transformations definitely in grade 11. You may, well, in grade 10, you would have applied these transformations as transformations to a quadratic function. Grade 11, I can't remember. I don't think in the 3C course you do this. Perhaps the 3M, I'm not sure. Anyway, we are going to apply these transformations to our trigonometry graph. So we're going to do it similar to the way we did vertical stretches and compressions. So we're going to do it by mapping notation, and then we're going to get some new points and plot those, okay? So a shift will appear after the function if it's a vertical shift. This person in, who's coming in, Brendan? Okay, so if I have to graph the function y equals f of x, and then I see a plus b after the function, I will know that this is a horizontal transformation because it is applied after the function. Okay, so anything that's done after the function, so whether it be sine or cosine, is going to be a vertical shift. If it's plus, it's going to go up. If it's minus, it's going to go down. So for example, y equals sine x minus 3. This is a vertical shift because it's applied after I do sine x, and it's negative, so it's going to go down 3 units. So you could probably, if it's just a shift, you could probably just apply this to the graph by looking at the main points. Remember, the main points on sine are here and to the left. So the main points are, where does it start, where is its maximum, back to the middle, where's the minimum, and then back to the middle or 0. So we could apply this by just moving those points up and down 3. Sorry, down 3. So this point would go down 3. I'll just estimate here. This point would go down 1, 2, 3. This point would go down 3. Running out of graph here. So we'll just extend this 3. This point will go down 1, 2, 3, and then this point. So here's my graph. Every point shifting down 3. Okay, and I could also do that on the left side. I could take every point and also shift those down 3. So this point comes down 1, 2, 3. This point comes down 1, 2, 3. This point comes down 1, 2, 3, and 3. So here's my graph. So here is the graph sine x, where every point has shifted down 3, right? Everything else stays the same. So the period stays the same, the amplitude stays the same. You'll notice now that the middle of the graph is at -3, right? So it was at 0, and now it's shifted down 3. We can also apply the transformation with mapping notation. So the x is not changing, but the y is shifting down 3. Okay, because it's a vertical shift, so it's going down 3. So I could list my 5 points on sine. So remember, you need to know these points. These are your critical points that give the graph its shape. And then you are going to apply the transformation by leaving the x the same and subtracting 3 from the y. Okay, so these are my points: 0, -3, 90, -2, 180, -3, 270, -4, and 360 back to -3. Okay, and the same on the left. So you can either, if it's just one transformation, you can certainly apply it to the graph, but you will be asked to provide the mapping notation. So the x stays the same, and the y, we're going to subtract 3. This one, we're just doing cosine x plus 2. So if I were doing mapping notation, the transformation is a vertical transformation because it is applied after the function being cosine x. So we're going to draw cosine x first, and then we're going to add 2 to the y values. So x stays the same, and we're going to add 2 to the y values. So remember, our 5 points on cosine start at 0, 1, 90, 0, 180, negative 1, 270, 0, and then 360 back to 0. So we'll write these out. And then we will apply these transformations to these points. So again, the x stays the same, and then the y, we're adding 1 to the y, or 2, sorry. So there's my mapping notation. Those are my new points, and then I could just plot those on. So the new point, I'll have to go up to 3. So we've got a point here, 90, it's at 2, 180, it's at 1, 270, it's at 2, and 360, it's back to 3. So there's my new curve. And then that would just continue here. This is going up 2, this is going up 2, this is going up 2, and this is going up 2. So each point on my graph is going up 2 units. And you will notice that the middle of the curve is now at 2, whereas previously it was at 0. Okay, so the whole graph has shifted up 2. Okay, horizontal shifts. So horizontal shifts will occur inside the function, meaning inside the bracket. So it will look something like this. So if I see a number inside that bracket, added or subtracted to the x, it is a horizontal shift, either left or right. And remember that transformations always do the opposite when it's applied to the x. And the main reason being is it's x minus d, so the transformation is d. So the minus was already there. So for example, if I graph the function cosine x minus 45, the actual value of d is 45, which is a positive value, which means it's going to shift right 45 degrees. Okay, so if I am doing mapping notation, this time my x is changing, and it's going to go to the right, so in the positive direction, 45 degrees, and the y will stay the same. Okay, so remember these are 90 degrees, so I could divide it into smaller units. So it is a cosine curve. I'm going to list my 5 points on cosine. And this time we are adding 45 degrees to the value of x. So 0 plus 45 is 45, and the y is going to stay the same. So 90 plus 45 is 135. 180 plus 45 is 225, and so on. And the nice thing about mapping notation is I can see what I need to, the numbers I need to put on my axes. So I know that I need to divide these up even further because I have to plot every 45 degrees. So this point 0, 1 is now shifted to the right 45 degrees, and it's still at 1. This point at 90 is shifted right 45 degrees, and so on. The point at the bottom shifted right 45. So my graph looks like this, and the same to the left. So this point moves to the right, the bottom moves to the right, the middle moves to the right, and the top moves to the right. So my graph would look like this, where it's shifted to the right 45 degrees. Okay, so this one is going to the left. So this is a horizontal shift. So remember, it's always the opposite with x. So it's a horizontal shift to the left, 45 degrees. So my mapping notation would be x minus 45 degrees because we're going left, and y will stay the same. So this time it is a sine curve. So always be careful whether it's sine or cosine. Sometimes we don't pay attention and we graph the wrong thing. So just be careful at which points you're using. And so to each x, we're going to subtract 45 degrees. So these points are now moving left. So this 0 is going, so we'll just divide it up into 45 degrees. So this point's going left, this top's going left, this middle's going left, this bottom's going left, and the end is going left. So my graph now looks like this, and likewise over here. So now the graph has shifted left 45 degrees. So inside the bracket goes left if it's positive, and right if it's negative. Okay, these are just questions from the guide. You are graphing sine, the original function, and then it wants you to shift it down 5 and up 1. So you can do that on your own. And then these are also from the graph. You have cosine. It wants you to shift the graph down 1 and then up 2. Okay, so those are horizontal shifts and vertical shifts. Our next lesson, I can't remember, just make